Hello, everyone, and welcome to the Counterpoint podcast. I'm your host, Peter Richardson, and today we're going to be talking about edge AI devices and how machine learning can be used in edge devices of all sorts. And to talk more about that and how these chips are coming to market, I'm delighted to be joined by David McIntyre, Vice President of Marketing at Perceive. Hello, David. How are you today?
Great, thanks. How are you doing?
Yeah, very well indeed. Very well. So this is kind of an interesting topic. So before we get into it, maybe you can tell our listeners a little bit about Perceive and about yourself, maybe?
Sure. So, Perceive is an edge inference company. We make a chip, Ergo, that's really applied to consumer devices or similar things you'd find in the home or potentially at work, where we're bringing intelligence to those devices. We were created and came out of stealth in March 2020. We're actually now about 3 years old from inception. And we were actually created in a public company called Xperi. Some people may know them because they own DTS and TiVo and HD Radio, where we kind of were a spin out to create this focused chip company. I'm responsible for marketing and product management and kind of new to the semiconductor world, but been in kind of the marketing and strategy and tech world for my entire career. So that's kind of us and myself in a nutshell.
Okay, great. Thanks for that, David. So I'm getting into the topic of AI and specifically kind of inferencing on edge devices. So I guess many consumers will be familiar with products like Amazon's Echo or Google Home that they can interact with, somewhat intelligently. So maybe we can start by discussing, the general need for AI chips in edge devices and maybe actually discuss exactly what an edge device is and what sort of problems that they can solve. So how would you go about discussing that?
Sure. So, first to clarify, when I say an edge device, and uh, edge is a term that gets bandied about a lot, and people have edge of network or edge servers. When I say edge device, I use a term some people call very edge. I mean the actual product in your hands. A phone, a laptop, a car, cameras, or if you were in the industrial world, a sensor on a piece of machinery. So it's something that is at the very edge and attached to probably sensors, cameras, microphones, inertial sensors, whatever. So that's the device we're talking about. And I come mostly from a consumer perspective. So let's take that doorbell or one of your Google or Amazon devices. They've traditionally been powered by the cloud. The sensor data comes to the device and it is flung up to the cloud. The cloud figures out what it is, what to do with it, and sends a response. That's cool. And it's created this class of devices that we all know and love. Many of us have those devices. I won't say their specific names so that everyone's devices don't wake up when they're listening to us, which is an interesting problem in and of itself. But now that we're doing that with the cloud, we're starting to see some of the challenges, whether it's privacy, power, latency. None of us wants a self-driving car that is sending sensor data to the cloud and then returning before it knows to turn left or to brake to avoid a child running across the street. So there are a bunch of reasons why we want to do our compute at the edge. And so the demand for edge AI chips comes from fulfilling that need to say, hey, and you see it even in, say, the Amazon devices. They now want to hear their wake up signal locally or commands like play, pause, stop locally. Those shouldn't need to go to the cloud so that we can get quick response and a device that people prefer. If you take a camera, do I really need to send all the video to the cloud? Or should I only send video to the cloud when something relevant happens? When a burglar is in front of the camera, you want to record that. But when the leaves are blowing and waking up your camera, that's not relevant video and alert. You really don't want that. And an edge chipset would be, for example, the way you filter that out, with the cloud only recording what really matters. So I hope that kind of frames where I'm thinking and kind of the reason why there is a market for edge AI chips and edge intelligence in general.
It does. I guess what the cloud provides is huge processing power, albeit that it can be somewhat distant from the edge as we've defined it. So, and I think you've explained very well why you wouldn't necessarily want to send everything to the cloud, but there is a lot of computational power in the cloud. So what, can we expect in terms of processing power in these edge chips? And what sort of things can they do? And perhaps also relevant is because we're talking about inferencing here. And I think one of the solutions that Perceive offer is, for example, recognize people that may be allowed to enter a premises or something like that. So how do you go about training a device in that context?
Sure. So when we talk about edge versus cloud, I agree. The cloud has a real place. The cloud is the big horsepower in the sky, and the edge is, let's call it the filtering, the detecting, the things that require immediacy. In terms of the performance people can expect, it's been growing a lot, as you'd expect. The chip world and innovation in general, there's been a lot of focus here. If I wind back the clock 2, 3 years, people were running very small models, maybe on an ARM based chipset. And you have a whole avenue called TinyML where people are taking these models and squeezing them on ARM chipsets or microcontrollers. And now you've really seen the emergence, the explosion of edge AI. Really kind of the big case would be like our phones. Apple just announced the iPhone 13 and the A15 Bionic chip, and it's got a large number of TOPS of processing mixed with everything else, much like Qualcomm did with their Snapdragon 888. But for more IoT devices, you're starting to see the emergence of edge chipsets that can do some of initially these basic tasks: detect a person, detect a pet, detect a vehicle, right? Those were the kind of initial basic things. I detect a keyword like, hey, insert a name, or play or pause. That's kind of where we were as of, I'd say, about a year ago, even now till today. What you're really starting to see with more powerful chips, and Ergo from Perceive is an example of that, is I can do those basic things, but now can I do more advanced language or speech recognition? Can I do audio detection? Glasses breaking, dog barking, baby crying. And can I even go further and say a vacuum cleaner wants to avoid obstacles? Roomba just announced their vacuum's ability to avoid messes left by your pets, that had created a humorous, if not mildly offensive set of videos on YouTube. We're seeing a lot of interest in the video conferencing realm, things like foreground and background, or doing gestures, recognizing there's a whiteboard behind you and unblurring the whiteboard. There are these kinds of things that are, I'd call it, the next generation of features beyond the basic detections. And those are now what people are looking to add to their products in a whole variety of categories. You mentioned face recognition. So, face recognition, and it's a bit of a dirty word, it's got some legal ramifications. When you're in a consumer device, face recognition is usually more of a convenience feature. Who's at the door, or everyone with an iPhone uses it to unlock their iPhone. And face recognition, when you're thinking about enrolling, add my face, that's not actually training. So, from an Ergo perspective, and most of these edge products, they're doing inference. Teaching a network to recognize a face actually isn't training in the neural network sense, where I'm creating a network. The network exists to create the map, the key points, and thus the hash for any face. And when you add a new face, you're creating the hash for, say, me, David. And all that's happening is matching. The network itself isn't learning David. The network is learning how to characterize a face. And then at the end, we're just matching if the characteristics of the face in front of the camera match the enrolled characteristics for David. So you're seeing some people beginning to talk about learning at the edge, but it's very new. I don't know if anyone's really deployed it. And with Ergo, we are not. We're all focused on inference.
Okay, got it. Thank you. Maybe we can talk a little bit about the Ergo chip, because I think its headline is, fairly significant performance at a very low power. So how would you sort of characterize that in terms of what it is able to accomplish? How does it compete with other solutions out there?
Sure. So the headline is 4 TOPS at 55 TOPS per watt, doing real neural network work in 20-ish milliwatts, give or take. And for sure, the interest we receive is heavily around being able to do a useful amount of work at incredibly low power. And actually, the offshoot of incredibly low power is very low heat. So, in terms of the kinds of jobs it can do, we've talked about it. All your usual detectors, that kind of foreground, background segmentation, keyword detection, and some basic speech, audio noise reduction, some basic kind of gesture or pose. These are all the kinds of examples of things you can do. For the technical people listening, you can run ResNet 50 and multiple things. We've run YOLO V5 at the same time as an LSTM based audio network or a TCN running audio. Face recognition is actually 3 networks in a row. So you can run a reasonable amount of things that allows you to get real work done, but we're not at the scale of some of these very large chips. The chips you would find in the cloud, 100 TOPS, 400 TOPS, 500 TOPS, but they're burning tens of watts. We came from the perspective of to be in the edge and to be exciting and fit with the needs of battery powered and small products. This has to be measured in milliwatts. You don't spending even more than 100 milliwatts becomes a challenge. And most edge chipsets today are 1 watt, 2 watt, 3 watts. They're single digit TOPS per watt. Some people are really excited about their 10 TOPS per watt. So the reason people look at us and why we're so competitive is we're doing useful work on par with other people, but at a level of power 10, 20 or more times lower. And that's the key differentiator for many people.
Yeah, and I think for me that's the most startling, aspect of this, that you're able to, as you say, achieve quite significant workloads, but with a very small footprint and a very low power consumption, which really seems to unlock a lot of potential use cases in these sort of edge devices. So in terms of the sensors that you can hook up with this, we've talked about cameras, talked about audio, um, other things, sort of mechanical accelerometers and so on. What are the limitations in terms of the type and number of sensors that you could hook up with an Ergo chip or an Ergo chip-based device?
Yeah, so it really comes down to the IOs we have on the part. So Ergo can support up to 2 cameras at the same time, 2 stereo microphones at the same time, and honestly, the vast majority of what we've been asked for by customers is audio and video. We do have the connectors to support other types of sensors, I2C, I3C, UART, a series of GPIOs. So we can support a number of other sensor types, but honestly, we haven't had occasion to really do that much and have been very focused on audio video just because that's where the market has taken us.
Okay. And in terms of memory, is there memory embedded in the chip itself, or do you use some sort of external memory? How should we think about how that would be configured?
Yeah, so a big difference for us versus others is we use no external DRAM, which is really important. It saves space, cost, and power. So there is SRAM on the part. A big part of our secret sauce is how we take these really interesting networks and applications and make them fit on a relatively small part. Ergo is 7 by 7 millimeter package and requires no external memory. And so that physical footprint and the resulting space savings, money savings, power savings is a big part of what's interesting and probably a little hard for some people in both the audience and our customers to wrap their head around. But it's our tools and our technology that really allows you to take those really interesting applications and fit them on this tiny part, resulting in that low power.
And you talked earlier about the fact that with many of the edge-based solutions, that send data back and forth to the cloud does pose a security risk. And I think one of the aspects that Perceive has talked about is the ability to do a lot more locally and therefore, contain some of that risk. So can you talk a little bit more about how you manage the privacy aspects and security risks by keeping everything much more locally?
Sure. So this is a natural offshoot of what you can do locally on the device, as you were saying, Peter. Um, I'll take the face recognition example because it's perhaps one of the ones that's more of a hot button. It is a hot button to many people because video is going to the cloud, it's being matched in the cloud, we're recording, we're tracking. And so, kind of the big brother aspect. And yet, I like face recognition on my phone, and I might want face recognition on, say, my doorbell to let me in. When you do things at the edge, depending on how you architect the device, you could send video to the cloud, but you can also be as simple as, say, in a door lock or a doorbell. I enroll my face, I walk up, the image sensor captures the image, Ergo runs the network and does the match or not. And all it could pass upstream is David or unknown, or it could even just work out with the system lock or unlock. So, from a privacy perspective, the image, and in fact, potentially the naming, never left the device. In fact, depending on how you set it up, could have never left even the sensor and Ergo. And so it creates a lot of possibilities to enable features while still respecting privacy because that video data isn't sent further along, or even biometric data can be kept local. When you can keep detection and the resulting application local, then you're back to Face Unlock on our iPhone, which didn't have people all worried from a privacy perspective the way face recognition is in cameras. And so it's this different and this local isolation that allows the privacy aspects to be respected while still getting the fun features that we want. And so it's really how you implement things that will determine what's possible, but allowing you to do the networks at the edge creates that capability.
Right. So, looking at how this is being applied, so you mentioned you've got quite a few customers that are developing different solutions based on the Perceive and Ergo platform. So, can you talk a bit about where the majority of those designs are being sort of focused? Is it a lot in this, security camera, domestic security area, or is it, more in sort of home appliances, or is the interest more in enterprise application? Where is that going?
So I'd say when we started out, we really focused on, I'll say, home security, consumer IoT cameras. That's where we started. And what was really interesting to me was how quickly interest ballooned very broadly. People came to us with things that, as a product manager, I hadn't even considered as markets. One such example being with COVID, we've all gotten behind Zoom or Teams. The video conference market, particularly hardware, cameras, laptops, have all shown up with their challenges and what they want to solve. That's not a market I even considered when we were doing all that work leading up to creating and launching Perceive and Ergo. So we're seeing a pretty diverse set. I'd say the focus laptops, video conference equipment, the security camera space, and then the burgeoning space of advanced wearables. I think that's going to be a space where we're going to see a lot of activity. Facebook put out their limited kind of Ray-Ban glasses with cameras and speakers. Snap has shown their more interesting glasses. Obviously, we've had Magic Leap and HoloLens around for a while. And I think these things we're working our way towards consumer interesting devices. And they're so focused on space, power, heat, and have a complex set of things they want to do that I think they're a great fit for the offering we have with Ergo. We haven't, as Perceive, really looked at industrial applications as much because our backgrounds are all consumer. I think there might be space for Ergo there. We just haven't pursued it and really focused there. So it's been mostly consumer products like the ones I was talking about.
Right. And in terms of the support that you provide to customers, I mean, you mentioned about the secret sauce of fitting, complex machine learning algorithms and networks onto what is essentially a pretty small chip. What else do you provide in terms of software and customization, reference designs, anything like that?
Sure, there's kind of two approaches. You can take Ergo as a solution, and we have person detection, face recognition, audio events like glass break. And that's kind of where we started. With the growth of neural networks and machine learning really as a discipline, we've really seen customers really want to move to what I'll call a platform usage, where they want to bring the networks and their proprietary data to do interesting things with Ergo. And for those people, we have a tool set which really is about bringing your network to Ergo, and then an SDK for all the software related work of plumbing your network within Ergo to the sensors, etc., as well as plumbing Ergo to the outside world. Are you connecting to an SoC or a microcontroller? Everything from as simple as how do I turn Ergo on or off or load a network onto Ergo versus how do I manage internally or externally frame rates and microphones and sensors. So we have that set of tools for both, let's call it the network piece and then the system piece. In terms of reference designs, we don't really have reference designs, but we do provide samples, so code samples and examples so that people can kind of get off to a quick start. As diverse as it feels the world of applications and neural networks are, it's actually not that many tasks when you look at, say, image classification or object detection. And so you can actually kind of have a handful of examples covering the majority of the use cases people are interested in to get them started in their work.
All right. So just before we wrap up, David, looking ahead, to the coming years, what are you most excited about? Where do you see this going?
So I think there's a lot of applications, and I think both Perceive and Ergo and the industry in general has an incredible opportunity to really reshape how we think about and interact with devices and really make devices work the way they should. We always talk about it. It's like you want these devices to work almost like there was a person operating them for you, not something where you have to kind of be very literal. And yes, you can talk to the device, but if you have to give it a string of literal commands, it was easier just to walk up to the light switch and flip it. So I kind of see for us some interesting areas that I'm excited about. One are those wearables. I think it'll really transform your ability to interact with people, things like live translation or reading signs or not staring down at your phone for maps, etc. I think drones and robots, when they have real intelligence to navigate, we gave the robot example, but if that home vacuum is driving around and keeping track of where things are, how many people are always wondering where their shoes are or where their teenager left something in a room that's impenetrable? Having the robot vacuum going around and just keeping track of where things are could be really valuable all the way through. I think we've already seen home security drones that can fly around, which I think will be a great target for many a cat leaping off furniture to take out of the sky. Or the drones, I'm into driving and cycling and the automation to have drones follow and get fun action photography. These are all things that people are working on, and intelligence will really help guide and frame what they're doing. And then appliances. I am a terrible cook, married to, fortunately, a woman who used to be a chef. And there's a lot of opportunity for automation and simplification. And my favorite example is the microwave. No one knows how to use a microwave. They know the 30-second button and the popcorn button. Why can't the microwave give me my Star Trek Next Generation? Picard used to say, tea Earl Grey hot. I don't even want to do that. I want to walk up to it holding a mug with water, and it goes, there's David. There's his tea. He likes his tea hot. And I just put it in and maybe hit a go button. There's a huge opportunity to improve the UI, the interface, that is needlessly complicated on a lot of devices, and for me, it's kitchen appliances, to simplify things, to do what we expected, not burn the toast. Everyone burns toast in toasters because you're setting time and slices. Can't the toaster just look and go, that's how dark he likes it, it's done? These aren't that hard. And so it's those kinds of things that I think really will be the next step, not some crazy Jetsons future, but a lot more advanced than we have now. And it's not that far away. I can already see how you would do it. And so I think this is within our kind of 3-5 year horizon.
It reminds me of I can't remember what the machine was called, but there was a machine in Hitchhiker's Guide to the Galaxy that always produced something that tasted almost entirely unlike tea. Whenever Arthur Dent asked for something from it like tea. But anyway, David, this has been a fascinating discussion, but I think we're going to have to wrap it up here. So that was David McIntyre, Vice President of Marketing at Perceive. Thanks, David. Been a fascinating discussion.
Thank you, Peter. Appreciate it. It was a lot of fun.
All right. And for everyone out there, thanks for listening to this edition of the Counterpoint podcast. And please check back in for the next edition. Thank you. Bye now.